Hello, I'm Dr. Harper. This video is an Operations Management BANA 3000 Section E01, Spring 2021. And this is week 4, the lecture on inventory. So let's bring up the lecture notes. On these lecture notes, I start with an introduction. Now, Chapter 12 in the text is Managing Inventory beginning on page 497. Now, this development that I'll do in this lecture will mostly follow the text with some added terminology. Also, not all the material in Chapter 12 will be covered. Here's the chapter outline. The importance of inventory, managing inventory, and even inventory models that will be covered. 506 on page 506, inventory models for independent demand, mostly covered. There's 2 techniques I will not cover. But probabilistic models, some covered. The part I will cover is just the definition of safety stock, not the calculation of it. And then the single period models and the fixed period models are not covered. So the importance of inventory, as far as the background is concerned, the takeaways is the primary function of inventory is to balance customer service level with inventory cost. In other words, satisfying the demand, the customer demand, while minimizing your cost to do so. So we're doing it efficiently, but also doing it effectively, but also doing it at low cost. Primary types of inventory are raw material, WIP inventory, which is work in process, MRO, which is maintenance, repair, and operations, and FGI, or finished goods inventory. So if you can visualize making tables and chairs, for example, well, the raw material would be the wood that's going to be used in making tables and chairs. The finished goods inventory is the tables and chairs. That's finished goods ready to satisfy your demand. But in the middle, you're going to have WIP inventory. WIP inventory is work in process that's partially made tables, partially made chairs, and wood that's not completely raw material, but it's being made into the product. That's called WIP inventory. And that WIP inventory could be very large, very small, depending on the efficiency of your production process. Now, MRO, maintenance, repair, and operations, would be the inventory that supports your operations. Things like your copy machine or the machinery that is used, the drills or the sanding machines that are being used to make the tables and chairs, or the lighting, or the chairs that you're sitting in, or the tables that you're using. So that's maintenance, repair, and operations. Managing your inventory. Well, we will look at managing inventory. We will look at this, example 1, example 2, page 502, 504, ABC inventory classification analysis. So this is one thing we will cover in this lecture. And also the inventory models. We'll be looking at the operating setup cost, holding cost, production cost, and the 2 fundamental questions of inventory theory: how much to order from your supplier, when to order, the order frequency, inventory period. So beginning right here, this right here is what I will be covering. Now, the 2 techniques I will not cover in this development is the production order quantity model and the quantity discount model. Those are the 2 I will not be covering. And in the probabilistic models, I'll do safety stock, stock level, and service level just by defining them, not really calculating them. And then finally, the single period model with a fixed period model here. This is assuming probabilistic models, which is referred to as stochastic models. Stochastic is the same as probabilistic, so stochastic demand and lead time, these models will not be covered. Okay, so let's go back and let's start. First, ABC inventory classification. This is page 501, managing inventory. The ABC, example 1, 502, and example 2, 504. So here's the idea and some definitions. Now down here below I have the definitions. So first of all, well, I numbered them 1 through 10. So we have 10 different types of inventory items. SKU. The textbook doesn't use the SKU term, but it's very common, and that's why I'm introducing it. SKU stands for stock keeping unit. It's a unique identifier of an inventory item within an inventory. Now, when you check out or buy something, they'll scan the barcode. Within that barcode is a SKU number, and that SKU item that SKU number will identify that item within your inventory. And so here are the different SKU numbers, and there's 10 different SKU numbers, so 10 SKU items. Now the units here is simply the total number of units that came into the inventory and gone out of the inventory over a year, and that's really referred to as turnover. These represent the units of turnover that came in and out of your inventory. This is the unit cost for each one of those items, of each one of those units of your SKU, and then you multiply those together, and that's called the usage. That's the annual usage. That's how many dollars has gone in and out of your inventory. Now that's total annual usage down here. The usage of dollars amount of inventory that came in and out of your inventory, and that's referred to as the dollar turnover. Okay, this is the unit turnover. How many units have come in and gone out of your inventory? This is the dollar. The usage is the annual usage is the dollar turnover. How many dollars have come in and out of that inventory based on the SKU item? Okay, then we take the total usage, we divide through by the total, and we get the percentages. And then we have a cumulative percentage. Column 7 is cumulative percentages. So we start with 38.7. 38.7 plus 33.18 is 71.97, plus 11.35 is 83. So we just accumulate or have cumulative percentages all the way to 100%. Now at this point, now on column 8, now we come to the classification in the ABC classes. So ABC classes is the roughly based on something called the Pareto rule. In other words, here's the Pareto rule. Class A, around 70 to 80% of the usage, dollar usage, is around 20% of the SKU items. Class B items is around 20% of the usage, is around 30% of the SKU items. And Class C is around 5% of the usage, around 50% of the SKU items. Well, look what this means. Let's come back up here. Well, here, 2 out of 10, or 20% of my SKU items, make up 72% of the dollar usage. So think of it. Almost over 70% of the usage is made up of only 2 items. So those are Class A items, which means they're very important items. We're going to really pay attention to those items. We're going to have a lot of our resources and effort and analysis focus on those A items. So this is where most of our effort goes. So ABC inventory classification essentially classifies the items into groups where very important, important, and less important. Where very important is the A items, you pay a lot of attention, a lot of effort, a lot of resources, a lot of analysis. The next is somewhere around 20%. Here I have 23%. They're called B items. And they're not, you don't have, and that's like 30% of your SKUs, 23% of your dollar usage. So this, your B items, and I lost a B in there. Let me put another B. There we go. There's 3 B items here. And the B items really say, well, we're not going to really pay a lot of attention to them as much as A, but more than C. And examples of B items would be like, well, I'm going to have qualified manuals that you can order out of. You can order out of this up to a certain amount. Or you have limits on how much you order those items. Or you can only order from certain vendors. These vendors are the B item vendors. And then finally, around 5%, around 50% of your items and 5% of your usage are called C items. Well, those are so low ticket items. Only 5% of your dollar asset is made up with half of your inventory items. So how do you manage those? Well, those are like price points. Those are the kind of things that, well, you know, I'm not going to be that concerned with the dollar amount because they're so small. I'm just going to order on price point. In other words, the cheapest ones. Order in bulk. Go to Costco and order a lot. Okay, go to Staples, and that's what Staples means. These are referred to as staple items. Things you need. Some of these might be MRO, are M&S, material and supplies, but they're C items. So just order in bulk, okay? Order large amounts. Okay, once we have the A items and B items and C items classified, okay, then from the classification we can create a cycle counting schedule. Not only do we have an analysis to determine our inventory policy, a lot of analysis here, some analysis here, less control here, but that control is on your inventory policy, which we'll do next. Okay, but also it's on cycle counting. So here, the A items here, the units here is the total number of units for my Class A items. So if I come up here, I say, okay, well, I have 1,000 of those SKUs, 500 of those SKUs. So how many units do I have in Class A? Well, 1,000 plus 500 is 1,500, and that's where that came from. I add up all of these. Those three added together turn out to be 2,900 units in that class. Same with the C. Add up the C items here. Whoops, wrong ones. C items, C units, and I'm going to have 4,150. So now the cycle count. Remember, I want to stay on top of my A items. Suppose I want to count them. I want to count them monthly. Count them much more frequently to keep on top of them, to analyze them in much more granular fashion. Monthly, sometimes bi-weekly, sometimes weekly. But here it's monthly. Now, in here, B items is quarterly, less, and C items is 6 months, just every 6 months, just order, maybe periodically. Now, we're assuming we have 20 days a month. If we have 20 days a month, then that will lead into 60 days a quarter, which is 3 months, and then 120 days for 6 months. Okay? And then the counts per day, we take the units here, we divide by the days, and we're going to count 75 A items every day, 48 B items a day, 35 C items a day. And so you notice my A items is pretty high, and then my B items is less, my C items is lower. And so maybe we want to adjust the units in our A class. Maybe we want to have more people counting. So this is a way to manage your inventory. Okay, that is your ABC classification. The takeaway, it classifies your inventory to know how to focus your effort so your effort has the most value in return on your asset. Okay, next let's do the economic order quantity. This is page 509 in the textbook. Okay, and here let's do the setup. Here's our inventory, and we're going to order items from our supplier and then receive those items into our inventory, so our inventory grows. We have demand from our customer, and then we will satisfy that demand by servicing that demand. There's a service level, and so as the demand is satisfied, the inventory goes down. So the inventory increases when we receive from the supplier. It goes down when we service the customer with distribution. So there's the idea of upstream supplier, downstream customer. Question. The fundamental question of inventory is how much do we order and when do we order? Where for the economic order quantity, we're asking the question, how much do we order? How much to order from the supplier. Now for the EOQ, the economic order quantity, to minimize the total annual cost of total carrying cost plus the total ordering cost. The answer, EOQ. So how much do we order from the supplier to minimize the total annual cost? EOQ. That's what EOQ will do. So let's develop it. Here we go. First, our demand, customer demand. Suppose it's 1,000 per units per year. That's the demand of inventory from the downstream customer. S is called the setup cost or the ordering cost. It's how much it costs to place the order. Cost to place one order upstream to the supplier. And that ordering cost is unit cost per your purchasing department or your buyers, people who place orders. H stands for holding. That's a holding cost, or the cost to hold or carry one inventory item for 1 year. That's your warehouse cost. So you have your purchasing and purchasers and buyers, and then you have your warehouse cost. And so these are the cost, $10 per order and 50 cents per unit per year. Now Q is your order quantity, and that's the quantity ordered from the upstream supplier. That's how much you're going to order from the supplier. This will answer the question, how much do you order? Well, how much do you order? You order Q. And we're going to calculate Q. Now notice we're calculating Q, the order quantity, but we're calculating it. If we calculated Q to minimize the total cost, that Q is called the economic order quantity, EOQ. Okay. Now that we're going to calculate Q, we're going to figure that out. We're going to determine that. But once we know Q, then we can take our demand up here, divide by Q, and that's going to be our order frequency. That's how many times we order Q over a year. For example, the demand is 1,000 per year. If our order quantity, let's say, was 10, then our frequency is going to be 100. We're going to order 10 100 times. That's our order frequency. If our Q here, let's say, was 500, we just have to order it 2 times to equal 1,000. So order frequency then would be 500 or 2. Okay. Now Q over 2 represents what is called the average inventory. That's the average inventory carried over a year. Now T, Q over D, or 1 over F, this is called the inventory period, or the time between your orders. Okay. In other words, if you're ordering twice a year, well, 1 over 2 means you're ordering, there's a half a year between your orders. If you're ordering 10 times a year, 1 over 10 is 1/10. You're ordering 1/10 of a year between your orders. Now notice, if the frequency is D over Q, then that means the inventory period is Q over D. Our lot size, let's say 500 items is our lot size. 500 over 1,000 is 1/2. That's 1/2 of a year. That's the time between our orders. Okay, now that we have these definitions, let's look at the costs. We have total ordering cost. That's the cost over the year. That's our planning horizon, a year, from our purchasing department. Well, that's going to be the frequency, how many orders we order, times how much each of those orders cost. And that's what S is, cost per order. Okay? And so there we're going to have cost per order times the number of orders. So D over Q times S. That's a total cost of all orders placed over a year. And that's the purchasing or buyer costs. Then the carrying cost, total carrying cost or holding cost. Total carrying cost or holding cost, that's your inventory cost. That's your warehouse cost. Well, that's your average inventory over a year times how much it costs to carry each of those items over a year, your unit holding cost. Total cost to carry an inventory, your average inventory over a year. And finally, your EOQ then is going to be the square root of 2 times D times S over H. That's the equation. That's your EOQ. That order quantity will minimize the total cost over a year. Well, where did the equation come from? Well, you can derive this equation very easily. The EOQ is your order quantity Q that results from a break-even between ordering cost and carrying cost. In other words, if I sum these two together, the total cost is, if I sum these two together, this gray here is my total cost. Okay, well, that's going to be a minimum right here, and that's when these two cross. And when these two cross, that's going to be a minimum. When they cross, that means the costs are the same. So I can take the ordering cost equal to carrying cost. Well, up here, my ordering cost is equal to this. So I bring this down. My carrying cost is equal to this. So I bring this down. And then I do some little bit of algebra here. Okay. I reorder this to have D times S over Q. I reorder this to have Q times H over 2. Then I divide through by h over 2 and divide through and multiply through by q. So I bring this q over here. I bring the h over 2 and divide. Then I bring the q on the left-hand side, q times q. And then I bring the 2h, the 2 in the numerator, 2 times ds over h. And then I take the square root of both sides, and there's my equation. Okay, this derivation is not important. You'll not see it on the homework. You won't see it on the exam. I'm doing it in the lecture to be complete so you can see where it came from. So it's not just pulled out of the air. It's actually derived from a break-even analysis over here on the graph and a little bit of algebra. We'll derive it. Okay. Another way to derive it is using calculus, but we won't go into that. Okay, calculations. So let's bring down these values up here. We have these values. Let's bring these down. Here we go. The demand's $1,000 a year. The setup cost is $10 per order. The holding cost is 50 cents per unit per year. My equation, my Q, which is EOQ, square root of 2 times D times S over H, 2 times D, which is 1,000, times S, which is 10, divided by H, which is 0.5, equals 200 units per year. Okay, how much do I order? That question is answered with Q or EOQ. I order 200 units per order. Let's go a little deeper. Okay, use this Q, EOQ of 200 units per order. Well, let's analyze this, and this will be on the homework. The frequency is D over Q. So I take my D, which is 1,000 up here, over Q, which is 200, and my frequency is 5 orders per year. So I'm ordering 200 5 times a year. That's my annual order frequency. Q over 2, 200 over 2 is 100 units, so my average inventory is 100 units per year. Okay, on the average, that's what I'm carrying. By T, my inventory period, the time between orders, is the reciprocal of 5 orders per year. 1 over 5 is 0.2 years, or D over Q, either one. So the time between my orders is 0.2 years. That's the time between the orders when I place them. So now I can take my total ordering cost, which is my frequency times my setup cost. 5 times 10 is $50. That's my total order or setup cost. My total carrying cost is Q over 2 times my holding cost. My average inventory is 200 over 2 times 50 cents is $50. Total carrying cost. Now notice that the total ordering cost is $50. Total carrying cost is $50. Notice they're equal, because the Q used in here, the Q that was used was EOQ, because that was EOQ, and there's EOQ. Because at EOQ, those two costs are the same from the graph above. And so I'm just demonstrating that that's true by the calculations. And there you go. Now, if Q is a little bit more, here's Q here. If it's more than 200, 250, well, then this right here is my ordering cost would be lower than my carrying cost. My carrying cost in blue is higher than my ordering cost. If my quantity is less than 150, then my ordering cost here is more than my carrying cost, and my carrying cost is less than my ordering cost. So they're equal only at EOQ. Okay? So let's go on. Let's go ROP, reorder point. This is page 512 in the text. And again, we have our supplier. Now, we had our demand here, and this is how much we order. But now, we ask the question, when do we order from the supplier, the lot size Q? Well, Q is how much we order. The question is, when do we order? Well, the answer is ROP. Another answer can also be T, the inventory period, time between orders. Okay, the approach here for ROP. The approach is from example 7, page 513, but I don't use those numbers. I go back to the example 3 that we did above on page 509. I use those numbers. Okay, here we go. The demand is 1,000 units per year, and we're assuming that the working days in a year is 250 days a year. Okay, so that's like 5 working days, 5 work days a week. There's 50 weeks in a year, 2 weeks off for vacation. They're not working 2 weeks in a year. So 50 weeks in a year and five working days per week. 5 times is 250 working days per year. So that's kind of where that came from. Okay, now the demand units per day then, I take the 1,000 demand per year, divide by the 250 days per year, and I got my demand of 4 units per day. So now I have my demand in days. So now I'm converting from units per year to units per day by dividing by the days per year. Okay. Now let's say the lead time was 3 days. This is the time between placing an order and receiving an order. The time between placing an order and receiving an order. Okay? In other words, if I place an order on Monday, I receive that order the next Monday, well then my lead time is 1 week or 5 working days. Okay, so I have to wait 1, 2, 3, 4, 5 days, and then on the 6th, 5 full working days, then on the 6th day, the next Monday, I receive it. After 5 working days. So 1 day would be Tuesday. If I ordered on Monday, 1 day would be Tuesday, 2 days would be Wednesday, 3 days would be Thursday, 4 days would be Friday, 5 days is the next Monday. Okay? So here, let's assume we have a 3 days lead time. So now the ROP, well the ROP is going to be, the equation is D times L. And you just multiply those two together. Okay? So the calculations, if my demand is 4 units per day, my lead time is 3 days, then my ROP is going to be 12 units. Well, let's look at this. Let's see how this works graphically. Right here, let's back up here. My EOQ is 200 units per order. So I'm going to order 200 units. But I have 250 working days a year. Okay? Or I have 4 units per day. Okay? So 200 units is the same as 50 days per order. In other words, if I take my Q over D, which is 200 units over 4 units per day, then how many days per order? It's 50 days per order. In other words, every 50 days, I place an order. That's my inventory period. So if I place an order on time 0, then on day 50, I'll place another order. Then on day 100, I place my next order. Day 150, I place my next order. 200, I place my next order. So every 50 days, I place an order. Because since it's 4 units per day, those 200 units will last 50 days. Okay? Because 4 into 200 is 50. So 1 order of 200 units will last for 50 days. Okay, well, my lead time is 3 days, which is ROP is 12 units per day. And that's going to be my demand during lead time. In other words, when do I want to place my order such that in 3 days, it's going to come in? In other words, here's when I want that order to be received, day 50. So I back up 1 day. Well, what's my inventory level? It's going to be 4. I back up 2 days. Well, my inventory level is going to be 8 because every day is 4 items. If I back up 3 days, which is my lead time, what's my inventory level? It's going to be 12. So I know that when my inventory level is 12, if I place an order for 50, in 1, 2, 3 days it's coming in, then that's when I want to receive it. That's when I want to receive my next order of 200. Okay, I'm placing right here an order of 200 to be received on day 50. I come back 1, 2, 3 days. That's equivalent to 12 items in my inventory. I place my order of 200 here. I receive my order of 200 right here, and then I do it again for the next period. Okay, so there's a concept. My ROP is 12, my lead time is 3 days. 1, 2, 3, 12. If I order my lot size of 200 there, I'll receive it in 3 days. Right when my inventory is 0, that's when I want to receive it. Okay, ROP, a reorder point, is the point of the inventory level at which an order is placed, which is 12. When to order? Order when the inventory level reaches 12 units. How much do we order and when do we order? Now we'll put them together. I order 200 units when the inventory is 12 units. So I order 200 units when the inventory level is 12 units, which is ROP. Or T is the time between the orders are placed. When do we order? I order every 50 days beginning on day 47. How much do we order and when do I order? I order 200 units every 50 days beginning on day 47. Because 50 days is my inventory period. So both of these will answer the question when to order. When my inventory level reaches 12, or I'm going to order it once every 50 days, beginning on day 47. Okay, good. Discussion. So here's our supplier inventory. Here's our input-output process again. For this development, customer demand is constant rate over time, and supplier lead time is constant. So this demand is constant and the lead time is constant. The demand and lead time can be stochastic or probabilistic. We don't get into that in this course, but it is in other courses and in graduate level. Okay, the two fundamental questions of inventory theory are: how much do we order from the supplier, and when do we order from the supplier? How much and when? How much to order is answered with the order quantity Q, or the economic order quantity EOQ, when the total cost TC is minimized. So Q when you just want a Q, but EOQ when you want to minimize your total cost. When to order is answered with either the ROP or the inventory period T, either one. The two fundamental questions can be expressed with either a continuous review system or within a periodic review system. So this will be on the homework and on the exam. The idea here is this: the continuous review system, the inventory policy, is expressed as ROPQ. The inventory policy ROPQ within a continuous review system implies the inventory level is continuously monitored or continuously reviewed until it reaches ROP. Then the lot size, or the order quantity Q, is ordered, or the Q could be EOQ. For example, if ROP is 50 and Q is 200, then the inventory policy is 5200, which implies order 200 when the inventory level reaches 50. And that's the continuous review system, because you're continuously monitoring the inventory level. The alternative, another way, is a periodic review system. Inventory policy is expressed as TQ. The inventory policy TQ within a periodic review system implies the lot size or order quantity Q, and that could be an EOQ, is ordered every T time periods. For example, If T is 1.5 weeks, that's the time between orders, and Q is 100, that's how much you're, and Q is 200, sorry about that, and Q is 200, and that's how much you're ordering. Then the inventory policy of 1 week 200 implies order 200 every 1.5 weeks. And notice that's assuming you started when you should have started. In other words, if you start ordering 200 every 1.5 weeks, that is when you order and how much you order. And you have to start it right with the lead time. Okay, so on this one you start at the right place, but then the inventory policy is just 200 every 1.5 weeks. So you're not reviewing the inventory level all the time continuously. It's periodically. When you review it every 1.5 weeks. Okay, probabilistic models. The stockout is defined as unmet demand. In other words, you have demand on your system, like a customer needs something, you don't have inventory to satisfy that demand. That's called stockout. Lost sales, lost image, maybe lost customer. So stockout is very costly. Companies do not like stockout with, say, large ticket items because you're losing a lot of money. The stockout level is the probability of stockout. So now we're looking at probabilistic models. A service level is the probability of no stockout. Therefore, the stockout level plus the service level equals 1. In other words, if your stockout level, and it can be expressed as a probability, let's say 0.1, it can also be expressed as a percentage, 10%. And I would use I'll use proportion and percentages interchangeably. So if your stockout level is 10%, then your service level is 90%. If your stockout level is 5%, your service level is 95%. They have to sum to 1, or 100%. Okay, now, suppose you had a very high stockout level of 50% or 60% or 90%. Okay, the probability of not satisfying your customer, if you have a very high stockout level, you have a very low service level. Remember, cost is one objective or one function. The other is your service level. You want a high service level, but maintain a low cost. Okay, so therefore, the stockout cost could be extremely high if the service level is low and the stockout level is high. So you want a high service level and a low stockout level. Well, how do you change these levels? How do you increase the service level and decrease the stockout level? By something called safety stock. Safety stock is inventory that is carried just to guard against stockout. So if you're afraid of running out of inventory, the logical thing to do is carry more inventory. And that's called safety stock. Okay? Now, as your safety stock increases, your stockout level decreases. Thus, your safety stock increases, the service level increases. Well, this should be logical if you think about it. If you carry more and more inventory, then you have more inventory to service your customer demand. Therefore, the service level increases. Therefore, your stockout level decreases. The more safety stock you have, the more inventory you have, the lower the probability of stockout. Okay, and this is just a glimpse into safety stock, because safety stock is popular. And we saw safety stock back in aggregate planning when we started talking about carrying more inventory, not letting it go to zero. We mentioned it back then. Well, more advanced courses, more advanced treatments of this will go into actually calculating the cost of stockout, cost of inventory, and also determining that within your aggregate plan. So the aggregate planning now and your inventory go together. They coordinate with one another. But within your inventory theory, you have all of this inventory definitions, terminology, concepts, relationships. All those now will be coordinated with all of your aggregate planning, level capacity, chase demand, and mix strategy. All those are going to be coordinated, and overtime. Okay? Well, that's all I have for inventory theory. I hope this helps. Any questions, make sure you post them on Q&A, and I will be visiting that periodically next week. And that's all I have for today. Between now and the next time I see you, take care.